Sessional assessments are 50%, midterm exam is 20%, and end of semester exam is 30% of the total, whatever that might be. Sessional assessment, the important thing is that you will be having 5 quizzes, obviously after midterm, because midterms are probably starting from 20th July next week. Your class advisor will notify you, or the schedule of midterm would be announced on the university. But I think as per university academic calendar, midterms are scheduled from 20th April. Sorry, 20th July, 20th July. So check it out from the university academic calendar. क्या करें नहीं sir, 3 अगस्त से है mid. Beta, who said 3 or 3rd August? I saw, if it's third, क्या foreign ईद के बाद है? Sure. Let me check on the academic calendar. Bachelor's program. यहाँ I, as per academic calendar of NED University, it says from 20th to 24th July. Whatever, check the calendar which is notified by your class advisor, and check the calendar of the university. But I think it's on 20th July. I'm not so sure about it, but as for academic calendar, it's 20th July. If your class advisor has said it's from whatever date you are saying, then go with that. But that will be announced properly on the university website. You will be given 5 quizzes. Best 3 scores would be counted. Those quizzes would be on Google Forms, and you would be given 1 or 2 homework problems, as well as a big project type thing. You would probably require to make some kind of a game or some application, simple application such as a tic-tac-toe game or a snake letter or something like that. Then you will be required to make this a big application in groups. Okay, that will be after midterm. The important thing is that the midterm would be from lectures 1 to 15. Like we have already covered that, or the live classes 1 to 5. So it's not a really long midterm. It will be simple C out, C in statements, and as well as some theoretical problems related to converting binary to decimal and decimal to binary in 2's complement, as well as the floating point format. So keep in mind that. Sir, Talha Javed mentioned 3rd August. Bhai, मुझे Talha Javed का नहीं पता. Go with your class advisor, or whatever your class advisor says, stick with that date. But as far as I think it's from 20th July. Check again from your class advisor. I will check again as well. Okay, and this thing is important, that the university administration has decided to award 10% of your total session marks, which is I think 5 marks, to viewing of recorded lectures. It was not notified earlier, but now it has been required, and we are required to keep log of who has seen the recorded lectures and who has not. So if you are sharing the recorded lectures from USB, or because not everyone has a very good internet connection, and I understand that a lot of students would be sharing the recorded lectures, or one of them would have been downloading those lectures, and he or she would be sharing with his or her friends. But here the university administration is actually recording, or is logging, who has actually downloaded or who has actually seen the recorded lecture using by logging in from his or her own account of cloud.ned.edu.pk. So I would suggest, if you haven't directly downloaded or not directly seen that, do it as quickly as possible, all the lectures. I'm not saying you have to watch them again, just download them, or somehow make sure that your attendance will mark over there, but just by clicking on download button and downloading a part of it, because I'm sure you have already seen all those lectures. But the university is actually generating some kind of a log, which is actually marking your attendance against that. And student attendance during live session, that is also being marked on your portal. You might have seen that. I'm not so sure whether your portal is being updated or not. So sir, I've downloaded lectures through IDM. Bhai, IDM क्या होता है? Instant download manager, internet download manager. Yes, but you have logged in from your Google account. Okay, so you must have logged in from your Google account, and you must have clicked on the class stream folder, and you must have clicked on that download whatever thing, so that the university system logs in or records who has downloaded or who has clicked the download button. So make sure you have clicked the download button at least once on those lectures. I'm not saying you have to download whole lecture, because it is understood that you might have shared with your own friends or something like that, because these lectures are big files. They are like 200 and 300 megabyte files, so that will just run out your internet connection really quickly. Okay, so coming back to this thing, if you have already seen this file, that's excellent. The next thing I want to discuss is this file. which I shared with you earlier, um, which was the complex arithmetic complex.pdf in the previous week. Some of the students, even myself actually, were facing some problems in using these complex numbers. So they are slightly different as compared to the normal real numbers. So here what you need to do is you have to include this complex header file. So once you have included this complex header file, sir, kindly provide assignment to prepare ourselves for midterm. Assignment to prepare? Beta, ye kya keh rahe ho? No, there is no assignment. Bhai, take a look at the lectures topic file which I've uploaded on G Drive. It's available on your class stream folder, and see the problems files. The problems which I've discussed, that is actually more than enough to prepare for your midterm. Okay, and some, like, I mean, lectures from 1 to 15 are really simple. I mean, you would be given some questions about how to write some program, write a program to display something, or you would be asked to predict the output of some program, or you would be given some MCQ questions, multiple choice questions, or you would be asked to figure out some error in the program, as well as you would be given one or two theoretical questions in which you would be required to use the calculator to figure out the binary to decimal and decimal to binary conversion for 2's complement and the floating point 754 IEEE format. Okay, so that's actually lecture notes are more than enough to do that. If you want more practice, even though you don't have much time because Eid is coming, if you want to do more practice, then I would suggest you do detail in detail end of chapter problem, which is your textbook. Okay, so coming back to our topic, we have to include the complex header file. If you include the complex header file, the CMath library also becomes accessible because CMath functions such as sine, cos, square root, tangent, or hyperbolic sine or hyperbolic cos, they are defined for both real numbers as well as for complex numbers as well. So we have essentially CMath functions are overloaded, and depends on what their argument is, they perform differently. I'm going to demonstrate that here. I've included CMath. It's not needed because once you have included the complex file, the complex header file, the CMath file is automatically included. I have defined a constant. I've defined a word pi with this thing. So whenever, if I'm using capital Pi anywhere in the program, that capital Pi is going to be replaced by this number. So whatever that number might be, and this number would be used in some calculations, and depending on, let me show you where I've used that. I have declared a number here. I have declared a complex number, and I have use a polar form. So this thing is pi divided by 3. So pi divided by 3, pi is given as double, and this thing is also, let's write in 3.0. So this thing is also double. So this whole expression would be double here because this thing is being assigned to double. If you want even more precision, you have to write long double over here. So if I want to use float, or if you want to use double, or if you want to use long double, it's up to you. I will be using double type only because this has double precision floating point. It's an 8-byte number, so it has plenty of precision. Not so sure it's going to store all these decimal numbers. And then I've used using namespace standard and integer main void. And now how to declare these complex variables? You just write the type. We have to write complex, and in these greater than and less than signs, we have to write float or double or long double. And then we just write the variable name with the semicolon, and that's it, depending on what type you want. Now, if you want to assign values to complex variables, or if you want to initialize them, so we have to write the variable name which was declared earlier. So I've just write variable name declared earlier. Let's call it, I've used that in an example. Let's call it result or p or whatever, or temp. And then this is important that you have to write complex double here again. You have to write complex double, and then in round brackets you have to write the real part as well as the imaginary part in round brackets separated by the comma. If you just write the number, if you just write a number, that will be assigned to the real part only. That will not be assigned to the complex part. So if you want to provide real as well as the complex part, you have to put them in parentheses, round parentheses separated by comma. You cannot write them like 2 plus ji as you do in your calculator. 2 plus I2 as you do in your calculator. You have to write the numbers in parentheses separated by comma for both real and imaginary parts. So here I have declared a variable. I have declared a variable complex double. That's a type. It's a complex number, and it will contain the real and imaginary parts in double format, so double precision format. And the name of that variable is image unit. So anything you want, any name you want. I have declared as Z1 over here because I've just copied it from the complex.pdf file. Then this is important. You have to write complex double here, and then you provide the real part as well as the imaginary part. So it's actually 0 plus 1 I here. Then I've declared another variable, which is the name is Z1. It's a complex variable, and I have written complex double here. You have to write it again here because you are declaring and assigning the variable at the same line. Then I have provided the -1 plus J2 or -1 plus 2I. I'll be saying iota as J because in electrical engineering, I is used for current. So we'll be saying J. Okay, now we have declared another variable that is a real variable, double x equals to 1.0. Okay, and then we now so far we have three variables, two complex and one real. The complex ones are image unit 0 plus J1, and this one -1 plus J2, which takes from here, and x equals to 1.0, which is a real number. Now if I declare a variable, complex double result, that's the name of another variable, and I've written Z1 plus image unit. So if the return value, if this thing is a complex number and if this thing is a complex number, the real part would be added to real and the imaginary part would be added to imaginary. So image unit was 0 plus 1j and the Z1 was -1 plus J2. So both of these things would be added. So that value 0 minus 1 would be -1 and J1 plus J2 would be J3. So the value of result would be -1 plus J3. That is, let's print that. I'm going to remark all these lines which I have written over here. So lots of remarks. So I'm going to delete that later on. So I'm going to run this line and let's see what we get. It says image unit equals to, and it's also displays the value of the complex numbers in rectangular format by default. You cannot change it into polar. I tried changing it into polar, but you have to write your own cout statement saying that this is radius and saying that this is angle. I'm going to discuss that in a few moments. So image unit is 0, 1 and Z1 was -1, 2 and x is equals to 1.0 or 1. Result equals to -1, 3. That means -1 plus 3 J. Now next line is, so if I delete this and okay, so result, now the next line is result plus equals to x. That is means result plus x. So x is actually a real number. X was actually a real number here, and we are just adding a real number to result. So after adding x, the value of x would be result plus x. So the real number would be added to this part. So -1 plus 1 would be equal to 0. And this line would be saying that, I think it should say 0, 3. So we have the real part equal to 0 and the imaginary part equals to 3. Now, if you want to if you want to see how Cartesian and polar form, Cartesian is the default way to represent the complex numbers. So I have a new value for result is result equals to, result was already declared earlier. So if you want to assign a new value to result, because previously result the value of result variable was 0 plus J3. So now it's I have assigned a value 2, -3. So I'm saying just override the previous value and the value of result would be now 2, -3 or 2 minus J3. So the new value of the complex number would be 2 minus J3 here. Now what I have done is that I have taken the real part of result, that would be 2, and I have taken the imaginary part. And the real and imaginary, these are actually the name of two functions which extract. Functions are essentially block of code which take in some value and maybe return some value. Not necessarily they return some value, but here they do. So just as if you write sine of, for example, 30 or 3 radians here. So sine is a function which takes a value or argument of 3 in radians and it returns the value of sine 3 radians, whatever that might be. So wherever that function is called, it's going to return some value. So here, this real function is actually defined in the complex header file, which we have included earlier. And the real function takes in the argument, which is the number result. It takes the result, which is we know that it is 2 minus j3, and it returns the real value, which is 2. And imag, image is imaginary, is another function which takes in the argument result, and it returns the value, the imaginary part, minus 3. So if we just write double a and double b, we say the real part of complex number result a is, or result is a, and real imaginary part of complex number result is b. So if we write this, so A and B are essentially what? A and B are essentially real numbers, because if we pick the result is minus 1, 3, after adding x, the value is 0, 3. New value of complex number result is 2 minus 3, and which is 2 minus j3, and the real part of complex number is 2, and imaginary part of complex number is minus 3. So we are just taking the imaginary part number. So that is actually a real number. If we append I or j to next to it, that will become an imaginary number. So we can store the imaginary part, which is the magnitude of the imaginary part, in a real number. So if you write a plus jb, so b is a real number and a is also a real number, and we are just storing the imaginary part to the real number b, and we're just displaying that. Now if we want to take the magnitude or the absolute value, which is essentially a square plus b square under root, or x square plus y square under root, we just use the absolute function abs, and we just pass the complex number here. And this absolute function takes a value or complex number, and it just squares the real and imaginary part, adds them, and takes the square root of that. The whole code is defined in this, the code of abs function, and it returns the modulus or the absolute value of this complex number, and that's it. So let's try running this code. So here say the modulus of complex number is 3.6055, so which is actually 2 square plus 3 square is actually 4 plus 9, that is 13. So under root 13 is 3.6055. So that is actually always a positive number. Next thing is, if you want to take the angle, angle means tan inverse. So angle here is argument result, and if you take the argument of result, so keep in mind that this angle is always given in radians. Radians is the default unit for angles. So if you want to convert radians into degrees, you have to multiply 180 degrees over pi yourself. So this thing is going to return the argument or phase angle in radians. So let's run this code again. And it says argument, or I have written the whole statement here, which is says that minus 0.982794. You also have to keep in mind that it picks up the numbers correctly, because 2 minus 3 is in what quadrant? It's in fourth quadrant. So keep in mind that the number has to be in fourth quadrant. The angle has to be in, I think it's in fourth quadrant. So I mean, minus 2 comma 3 is different than 2 comma minus 3. I hope you understand, even though tan inverse would have been the same number, but keep in mind these small details. Okay, so now we have declaring, if you want to declare a complex number in polar form, so what you can do is you can declare a complex number, complex double p, and just write polar here. So if you just write, do not need to write complex double. If you want to, I mean, this compiler is speaking, I mean, if you write this thing is as given in the handout, but this compiler is actually giving error here. So just write polar here, and I've written 1 comma pi by 3. So what I've written here is, this is 1 e to the power of 1 angle 60 degrees. That's what I have written over here. So pi is actually 180 degrees. 180 degrees divided by 3 is 60, but this compiler or this computer actually takes the values in radians. So pi is, number is 3.14 divided by 3 is something like 1 point something. That is taken in radians, but behind the scene this is actually 60 degrees. So what is this pi? This pi is defined here. So whenever I'm using this word is replaced by whatever value you have typed here, and based on whatever the context it is being used, so that number is being divided by 3.0. So this is a double value, and this polar number, we just written the name as p, is a complex number, and it has the radius of 1 and angle of 60 degrees. So if you want to write 1 angle 60 degrees, you might have written that, or 1 e to the power j 60 degrees, or 1 e to the power j pi by 3. If you want to write, I can write somewhere here. So I can just write one angle 60 degrees, but since the default angle is radians, since that would be pi by 3, or actually there's 1 into the power j pi by 3. So that's what we have written over here in polar form. So value of p is, once again, if we just write the value of p here, so if we write, run this code quickly again, actually this thing is going to be displayed, is value of p is 0.5 comma 0.866. So that is 0.5 is 1 over 2 comma under root 3 by 2. So the default way to do, even though we have declared it as a complex number in polar form, but the computer would always display in the Cartesian or the rectangular form. Defined operators are assignment operators. We have used that. This assign operator is used here. Arithmetic operators are plus, minus, divide, multiply, easily used. Remainder operators is not used with the double or the floating point numbers, only used with the whole numbers. So the default type is either double, floating point, float, or long double. So obviously remainder operator is not being used. One more thing which somebody has asked, I don't remember who, the remainder operator can be used with negative whole numbers. No problem with that. So I think in some lecture I probably forgot to answer that question, but that remainder operator can be used easily with negative numbers. But the only restriction is you cannot use it with fractional numbers which contain some numbers after the decimal point. You cannot use the remainder operator there. Combined assignment operator, which is a compound assignment, you just add the numbers and update them, or subtract the whatever number here and update the value. It's easily used with these complex numbers, depending on you're adding the complex numbers or subtracting some real numbers. You can easily do that. Comparison operators are used whether you have to tell them whether some number is equal to some other number or some number is not equal to some other number. The comparison operator would either return true or false, but you cannot use the greater than, less than equal to, or greater than equal to with the complex numbers. Reason is complex numbers are defined in two dimensions. So we have the x dimension as well as we have the y dimension. Y dimension is actually 90 degrees away from the x dimension. For computers, everything is a number. So I hope you know what is under root minus 1. Everyone knows what is under root minus 1? Answer, type, anyone type what we mean by under root minus 1? Or what is the behavior of under root minus 1? Okay, it's iota, but exactly what is the behavior? We don't know the value. We don't know the value of under root minus 1. We only know the value of we only know the value of we don't know the value, but we know the behavior. It's really simple. Okay, let's say we have a vector, and let's make another vector. Sorry, let's say we have a vector and it's pointing in the leftwards direction, and the radius of this vector or the length of this vector is, let's say, for example, 2, and obviously angle is 180 degrees. So if I multiply this vector, with minus 1, what would happen? Obviously the vector would flip its direction to 180 degrees. Okay, so if we multiply this vector by minus 1, this vector would flip its direction. Let's say if you have a vector pointing in this direction, we multiply with minus 1, the vector would point to the downwards direction. It will just flip its direction 180 degrees. So that means that if you are multiplying a vector with minus 1, it is actually changing its direction 180 degrees. So multiplying it by minus 1 means if I multiply this vector with under root minus 1 twice, we will have the same result, which is saying that direction change. So if we multiply under root minus 1 and under root minus 1, we are essentially saying we are multiplying a vector with minus 1. So that is resulting in the changing of direction of 180 degrees. And let's say if you multiply a vector with under root minus 1 only once. So obviously if you are multiplying it twice, so that was causing the vector to flip its direction 180 degrees. If you are just multiplying with under root minus 1 only once, so that the vector would flip 90 degrees. So the important thing to remember is, even though we do not know the numerical value of under root minus 1, but we do know that whatever number you are multiplying with under root minus 1, you are changing the direction of that number by 90 degrees. So if we are writing a plus jb, so a is actually the x-axis and b is 90 degree out of phase with a axis. So or if you could just write x plus jy, So y is 90 degrees away from x, but y is a real number and x is a real number, but j only signifies that, or iota only signifies that y is 90 degrees away from x in counterclockwise direction. Or if you have a under root j, that would be rotating the vector in clockwise direction. So this is very simple thing for computer. Everything is a number, and behind the scenes that computer just takes those numbers, real numbers, and apply some special arithmetic. Because if you're multiplying a plus jb and into a minus jb, so j into j would be -1, and it would be having some special instructions to handle those numbers and assigning the real number to real part and imaginary numbers to imaginary part. So we were discussing the comparison operator, and this comparison operators cannot be used because we have two numbers in each complex number. We have an x number and we have a y, and also if you have another comparison, if you have another number, we have two numbers again. We have an x and we have a y. So how can we compare whether something is less than or bigger than as another thing? So if you really want to compare, even though there is no logical sense in doing that, so if you want to compare these, then compare their real and imaginary parts separately, then make a decision whatever logic you are making there. So if we just write t is greater than result, it will not work because this thing is not defined for the complex numbers. So this thing is not going to work. So if you want to compare real and imaginary parts separately if you want to. Okay, some few last things. जी जी अटेंडेंस होने वाली, बस 2 मिनट सबर करो. Okay, few last things. C out equals to norm, or norm means multiplying that number with its conjugate. It will give out the if you just multiply a square plus b square, and conjugate is actually just taking the negative sign, multiplying the negative sign with the imaginary number. Okay, complex double temp. You can also use the trigonometry function. These trigonometry functions are defined for both real numbers as well as for complex numbers. If you're passing the argument of complex number, the return value of this function would be a complex number. If you're passing the argument as a real number, the return value for these function would be a real number. Similarly, if you want to use cos of this thing, and if you want to take the inverse sign in calculator, yes, I will inshallah. Okay, I will upload this file. If you want to take the inverse sign, take the arc sign or cos or arctan. Similarly, if you want to use hyperbolic functions, so if you are developing the solution for some differential equations in Cartesian system, so you probably would be needing to have some hyperbolic functions. So sine h, cos h, tan h, and a sine h, a cos h, and a tan h. They are both defined for complex numbers as well as for real numbers. And last few things, which is power of function. Power of function is defined in math file, C math. If you take a number and raise it to power a complex number, obviously that will be a complex number. And you cannot do this because here this argument has to be a complex number, which is usually for floating point or double point. You cannot pass an integer here. If you just do this, it will put on some error. And you can use a complex number to raise to some power, or you can raise a complex number to another complex power number. So depending on what you want to do, if you want to take e to the power some complex number or log of these complex numbers, you can use these functions, exponent and log. And it appears that the output format is a Cartesian for both. Yes, it is. And the phase angle is this. Even though we have taken the polar numbers, but we will see a rectangular format system over here. So let me check. Okay, so we were doing this value of p given in this rectangular system. 13 was this argument. I don't so sure whether 2, 3 was. Sign of the complex number is this thing. Once again, pass in the complex number, the sign of that would also be a complex number. So it's actually performing the formula of sine alpha plus beta, if you know. So sine alpha plus j beta would be applied here. Cosine of the number, cos alpha plus j beta is applied over here, and a big calculation behind the scenes. Hyperbolic sine, sorry, I've written that is this thing. I've written the statement wrong here, so just ignore that. Demonstrating the power of this thing, you can raise the complex number to any power, or you can raise a double number to any power, and you can raise a complex number to any complex number power. So once again, last thing is the default way to display the complex number is Cartesian. You want to if you want to uh, display a polar form, you have to develop your own cout statement. Yes, I will upload this lecture. So just I think that is end of this class. Don't go anywhere. I have to take the attendance. So let me check the attendance. How many students? 116. So this thing is 1, and this thing is 2. Okay. Okay. I think everybody should sign out now. If anybody wants to ask any question, he or she can ask in the chat window. And rest of the students are supposed to sign out right now if they don't have to ask any questions. So, and that's it. I'm turning off the microphone. Everybody wants to ask any question, right in the chat window. And even though I'm not turning off the microphone, let me check. 3rd अगस्त एडवाइजर को मैसेज किया था सर, भाई मुझे नहीं पता, एडवाइजर से पूछना हूँ। तला जावेद ये भी हो गया सर, अगर डाउनलोड करके देखे तो डाउनलोड का एनी इशू। Look, you have to click on the download link and you have to download some part of the lecture. Okay, if you don't have much internet, just download it so that you're logged in as the downloader from on the attendance portal of the university. University is keeping 2 separate logs for your attendance. One log is for live class, which I have taken attendance right now. Another log is for the recorded lectures. If you have seen the recorded lecture, and look, if you have taken the recording from if you have a friend who has given you on some DVD or some USB disk or whatever you might have downloaded from his own computer, that you will not be marked present on the university log. For that, what you need to do is go on the class stream website in the very beginning, from the, I think it's for beginning of this month or the previous month. I think the classes started on 8th of June, if I remember it correctly. If you haven't directly downloaded it, log in from your own Google account, click on the download. If you don't have much internet, don't worry, at least click on the download link, and then if you want to, you can just disconnect, because I know you already have the USB files with you. Okay, so that if you click on the download link at least once, so you will be marked as present in the log of the university. Okay. Zahir Hussain, sir, my grandfather, क्या लिखा है? ओ नलिल्लाह, अच्छा भाई अल्लाह उनकी मग़फ़िरत करे। Grandfather passed away. By attendance rule would be provided by your class advisor. I'm not so sure whether it's 75% or 80% for live class. I have absolutely no idea. If you have a genuine problem, make sure you have your application ready. And Khuda na khasta, if you are short of attendance, contact your class advisor as soon as possible. So because this attendance is generated by computer, I cannot override the file, because this file is generated by the computer and sent to your portal, so I cannot do that. Sir, complex number आएंगे mid में? No. Complex, the course of the midterm is from lecture 1 to lecture 15, the recorded lectures, and what was the next part? And the live lecture 1 to live lecture 5. अच्छा, मोहम्मद शरीफ से लेक्चर्स अगर क्लासरूम से लिए हैं, डाउनलोड नहीं करे तो कोई अटेंडेंस लगे? भाई no, you I mean, if you have clicked on the download link, or if you have viewed the lectures, that is also okay. If you are just playing directly from the classroom folder, provided you are logged in from your own account, yes, you can do that, no problem. If you just log in from your class account and then just click the play button, if I'm not wrong, that is also logged in, that you have viewed the lecture. Set precision, once again, like set precision, do it yourself. Put like 2 or 3, whatever precision you want. That would be the amount of numbers that would be displayed, including the real part as well as the fractional part, and that's it. I mean, it's really not that important, because behind the scene computer is actually using the whole precision which is available to it. It's only displaying those numbers. It's not using, and it's not set precision does not contribute to your compound errors if you are using the result in the subsequent whatever computations. Okay, ABS means absolute value. सर थोड़ा स्लो बोले, अब क्या करें यार, आधे घंटे की तो क्लास होती है. अच्छा, फिर उसके बाद क्या लिखा हुआ है, अटेंडेंस हो गई है. Mohammed Sarim says that Sarim, can you pose some practice problems to help us prepare for mates? To prepare for mates, you have to see the practice problems as well as the theoretical lectures. I have practice problems in the recorded lectures as well as the handwritten notes in the recorded lectures, in which I have converted from hexadecimal to binary to octal to whatever number system. Okay, and 2's complement as well as floating point to आएगा. सही है. So make sure you understand it, and also 2's complement भी आ सकता है. So make sure floating point and 2's complement, you should know how that works and how that precision works. Sir, can you pose some, भाई हो गया ना. अच्छा, अब फिर complex numbers मिड में नहीं आएंगे. सेट प्रेसिडेंट वंस अगेन 182 प्रेजेंट है, कितने मिनट तक देखने को आपके व्यू हो यार, ये मुझे नहीं पता. गुड क्वेश्चन अरसलान अहमद, एक्सलेंट क्वेश्चन. एब्सोल्युटली नो आइडिया. मेक श्योर 5-10 मिनट तो देख लो. अच्छा सर कितने मिनट तक नहीं हो गया. अच्छा, द ड्यूरेशन ऑफ मिड टर्म इज एज पर इन योर पीडीएफ फाइल इज गिवन लाइक 2 hours. Not so sure whether that would be 2 hours for the whole paper, or it might be possible that midterm is of lesser duration and you would be asked to upload the snapshot of whatever you have written on your paper on the Google Drive and share it with me. Make a PDF file of that. So I think that time includes because you would be required to write something on your notebook. So make sure you have a notebook as well as the calculator as well as a paper in front of you, and preferably, yeah, and you have to have some kind of a camera available with you, or you have to have some kind of a scanner with you, so that you can upload the solution, the handwritten solution in question number something, to the Google Classroom. Okay, jazakallah for everyone. Inshallah see you next week. Allah Hafiz. And भाई जितने लोग हैं वो सब sign out करें.